This is Ham College, episode 39 for March 31st, 2018. Ham College is brought to you by ICOM. From D-Star to SDR, ICOM uses the most advanced technology in their radios. And by hamstudy.org, a great way to study for your next license exam. Hi, welcome to Ham College, episode 39. I'm Professor Thomas.
And I'm Dean Martin.
And you know, we always try to provide the best in cheap jokes here.
And sometimes we provide them more than once.
Yeah. Some of them are just so good we have to keep reusing them, you know. But, hey, you know, there's no additional charge for that.
You got to get the mileage out of them while they're still rolling, man.
Yeah. When you've got so few like us, you need to use them as many times as you can. Well, we've got a fun show lined up tonight. We're gonna do a few interesting things.
Yep.
What did we talk about in the last show?
We talked about digital modes.
We did. We completed talking about CW.
Mm-hmm. And I believe we touched on RIDI.
We did.
Yep. That's what we did. All right.
And we talked about grounding. And we got that.
Oh, yes, the controversial grounding.
Yep. Tonight, we're going to talk about, well, some more digital modes because there's a lot to be covered there.
Yeah.
And we're also going to talk about interference and noise. And there's a lot to talk about there, too.
It sure is. And some of the digital stuff, I'm kind of concerned about that because I'm not the biggest digital guy around, so I fully expect to hear that buzzer at least once tonight.
I'm thinking a lot of these questions weren't on here when we took our general exams.
Yeah, because I don't recall them.
I don't either. Y'all better be ready tonight. It's going to be a few tough ones in here.
Yeah, put on your thinking caps and. This is a pretty intense one, so there'll be no hall passes given out during class today. So I hope you went to the restrooms before class started.
But we will have a 4-minute recess mid-show.
That'll work. So you can go pretty fast then.
Unless you're old, it might take you a little longer. Okay, enough of that. Are you ready to get in straight to the questions tonight?
Yep, I'm as ready as I'm going to get.
Which mode is normally used when sending a RIDI signal via AFSK with an SSB transmitter? Is it A, USB?
B, DSB?
C, CW?
Or D, LSB, or lower sideband?
That's LSB, not LSD.
Yeah, don't do LSD.
No.
Which mode is normally used when sending a RIDI signal via AFSK? I believe the answer is going to be D, lower sideband. But I honestly don't remember. I'm not the biggest digital guy, so we'll see how that goes.
Well, the few who are taking a stab at it in the chat room.
I think I need to change mine to A.
No, you said, what did you say, D?
I said D, lower sideband, but I don't. You know what? I don't know that I've actually made a RIDI contact. I've listened, copied it some.
Yep.
But I don't know that I've used it.
Well, here, I need to get ready for this one. If you'll give me just a second here.
Hold on, I didn't bring the fire extinguisher.
Well, let's see, Tommy. It is D.
Whoa.
Lower sideband. How about
Whoa, I stumped the chat room.
Yeah.
Or you stumped the chat room. I can't believe that.
Wow, nobody guessed it. I told you there were going to be some tough ones tonight.
That was easy.
You wanted to change your answer. So
it wasn't that easy.
And I was all prepared right here. I got the buzzer ready to go.
Hold on, man. I almost lost an eyebrow there with that flash.
Yeah. If you wake up at midnight and you can't see, then
nobody can even see what you've got up there.
I know. That's
the beauty of it.
That's the beauty of it.
The original pine board transmitter.
Look at that nice little arc there.
With sparks and everything.
Yep. Sounds better on the table.
Yeah.
Anyway, we'll look at that a little later. I've got that there for a reason. Well, Tommy, somehow you got that one right. Have you got one for me to miss?
That was a near miss. Okay. Which of the following which of the following describes a waterfall display? Oh, this would be an easy one, man. A, frequency is horizontal, signal strength is vertical, time is intensity.
B, frequency is vertical, signal strength is intensity, time is horizontal.
C, frequency is horizontal, signal strength is intensity, and time is vertical.
Or D, frequency is vertical, signal strength is horizontal, and time is intensity. That's a lot of words there. It's the same ones over and over. I'm going to have to look at it again so I can think about it. Let's see. Frequency is horizontal. I'm going to say that's correct. Signal strength is vertical. No, that's not. So it's not A. B, frequency is vertical. No, frequency is not vertical, so it's not B. C, frequency is horizontal. Signal strength is intensity. Time is vertical. That's not right. D, wait a minute. One of them's got to be right. Frequency is horizontal. Okay. Time is vertical. Signal strength is intensity. It's C. Frequency is horizontal. Signal strength is intensity. Time is vertical. Well, let's see. I'm going to say C, Tommy. That's what they're saying over in the chat room. So let's see if I'm right.
Okay.
Here we go. Give me one of those. That's some waterfall goodness right there.
Yeah.
Which of the following digital modes is designed to operate at extremely low signal strength on the HF band? Is it A, FSK 441 or Hellscriber?
B, JT9 and JT65?
C, Clover?
Or D, RIDI? Okay, so we talked about RIDI last time, and while it'll work at fairly low signal, but it's not. There are others that operate a lot lower, because I do remember we talked about that in the lesson. I don't even know what Clover is. I've never heard of that.
Let me give you a hint.
Well,
according to the chat room, it's either A, D, or B.
Okay. Well, I think the answer is going to be B, JT9 and JT65, because I do know they're popular for being able to work pretty low signals. I think that's the answer. I don't know for sure, but I'm pretty sure that's right.
I believe you're right, too. Let's see. There you go.
I just don't remember any of that stuff being, like you said, on that test before.
JT65 hadn't even been invented then, so we know that couldn't have been one of the answers.
It's been that long? Is it that new?
I think so, isn't it? Yeah. So anyway, yeah, the two JT modes, those are the ones that work practically in signals you can't hardly even hear. You might not even know we're there. So
is Clover a real thing? I've never heard of it.
I want to say it is, but I don't remember.
Okay, so your answer is going to be B, bravo.
Yep. JT9 and JT65, thanks to Joe Taylor and crew.
Yeah, he's a pretty popular guy. What is the standard sideband? This is almost cheating now. What is the standard sideband used to generate a JT65 or JT9 digital signal when using AFSK in any amateur band? A, LSB or lower sideband.
B, USB.
C, DSB.
Or C, SSB. Well, I don't see how this is cheating. If you don't know the answer, this could be a really tough one. And just so
I don't know the answer either because I thought I would know it at first when I saw the question, but no.
Yeah. All right. So what is the standard sideband? Well, it's not DSSB because that doesn't specify which sideband it is. It's not DSB. That's double sideband. So that's two sidebands.
That's all of them.
So it's got to either be lower sideband or upper sideband. I'm just going to take a wild guess here. I think it's B, upper sideband.
I think so too.
Because I think it's the opposite of PSK 31. And, oh boy, there must be a lot of JT65 folks over in the chat room there because almost everybody said it's B.
Yeah, well, there's some A's in there also.
Yeah, there is. But it is B.
But you nailed it.
Yep. By luck.
Hey, it worked for me. I'm claiming it.
I will.
So take it when you can get it, man.
In what segment of the 20-meter band are most PSK 31 operations commonly found? A, at the bottom of the slow scan TV segment near 14230.
B, at the top of the single sideband phone segment near 14.325 megahertz.
C, in the middle of the CW segment near 14.100 megahertz.
Or D, below the RIDI segment near 14.070 megahertz. And it just so happens that I was paying attention last month and I know the answer to this one.
Yep.
So it's going to be D, below the RIDI segment near 14.070 megahertz.
I just happen to have been paying attention too, and we discussed that pretty thoroughly.
Yeah, we did. So
I'm going to say it's D as well, just like...
it looks like everybody in the chat room.
Yeah. There we go. D. Below the RIDI segment near 14.070.
It actually paid off for me not to be sleeping in class that time.
Yep. It did. Okay, next one here.
Okay, which type of code is used for sending characters in a PSK31 signal? A, varicode.
B.
Yeah.
Vitarabi? Viterbi? Something like that.
C, volumetric.
Or D, binary. What type of code is used for sending characters in a PSK 31 signal? Well, I just happen to know the answer to that. But first let me say number B and number C. I've never heard of either one of those before.
Me either.
I've heard of binary, but yeah, I don't think that's it either. I believe it's a varicode. And we're getting some D's and some A's. It's got to be one of those two. I'm pretty sure. I'm gonna say A though. Let's see. And it is a varicode. And we're going to talk a little more about that here in just a moment. But that is pretty interesting stuff there.
Yeah, it is.
We don't want to give away the whole varicode secret just yet because we've got a couple more questions like that we could stump some folks with.
Right. So, but after we finish them, then we'll circle back around and discuss a little bit, which is kind of cool stuff, I thought. Yep.
All right, then let me ask you this.
Okay, well, hit me.
Which of the following statements is true about PSK 31? A, an uppercase letter makes the signal stronger.
B, Uppercase letters use longer varicose signals and thus slow down transmission.
B. Varicode error correction is used to ensure accurate message reception.
Or D. Higher power is needed as compared to RTTY for similar error rates.
Okay, I think you can probably rule out some of those pretty quick there.
Yeah, I'm going to go ahead and uppercase. I'm having a hard time seeing it tonight for some reason. Higher power is needed as compared to RTTY for similar error rates. I don't think that's the case. D. Varicode error corrections used to ensure accurate message reception. No. I think uppercase letters are longer. I think it's going to be either A or B.
Okay.
Uppercase letters make the signal stronger. No. Uppercase letters use longer varicose signals, thus slow down the transmission. That's the one I think it's going to be B.
Do you think it's going to be B?
Yeah.
Well, let's
And
see.
the only reason I say that is because of the thing we got coming up in a little bit we had to work on. But I would have, I'm not even sure I'm right, but I think I am.
Most folks are saying B over in the chat room. I'm going to agree with you. I think it's B as well, which I did not know before I started typing in the questions this time around.
Yeah.
You'd think, man, that sounds like a bogus answer there. But,
But you'll see why it's
Yeah.
true shortly.
okay. Well, we got one more on varicode. Well, it's not varicode, but similar.
How many data bits are sent in a single PSK31 character? A. The number varies.
B, 5,
C. 7.
or D, 8. And, I thought about this for a minute, and the name varicode, that tells me something's variable in there.
It lends you to believe that.
Yeah, I'm going to think the number varies. But, we got A's and B's in the chat room over there. Well, let's see what it is, because I almost thought it was 5 as well. That was another guess I had early on, but I'm going to say it's A. And it is. The number varies.
Yeah.
Well, that's kind of strange, because usually in digital transmissions, your data bits are always the same, aren't they?
Yeah, pretty much.
Yeah, serial,
Typically.
yeah, everything, yeah.
In fact, that's actually kind of how it works.
So you want to do a little explaining?
You got some explaining to do?
Yeah, right there.
Yeah. This is actually the varicode alphabet and character set here for English language. The length of the varicode is different based on the character. So if you're going to tell somebody about your toe, a lowercase t is 3 characters, the O is 3 characters, it's 1, and the E is just 2 ones.
But go back to the T's there. Varicode, you said the T is only 3 characters, it's 101.
Right.
But
The lowercase
over,
t.
Yeah, over the uppercase T, it's 1101101.
Right. So, but that goes back to that question. The uppercase characters, if you send everything in all uppercase, then it's going to take a lot longer to send your transmission than it will the lowercase characters, for the most part.
Yeah.
Because typically, if you look over there on that third column, the lowercase characters take less bits.
Yep.
It almost looks like binary, but typically binary is the same depending on the length.
Well, because all those, like a lowercase e there is just 1, 1. A binary, that would be padded with leading zeros at the front of it to make it however many bits that it actually
8
needed
bits
to be.
or 16 bits or whatever the word is.
Yeah. And, yeah, that was a pretty good idea to come up with PSK31 and to make it more efficient. If you don't have to transfer as much information, you can get a faster data rate.
Yeah, and that's a good reason to get that caps lock off.
Yep.
Besides, it looks like you're hollering.
Yeah.
But it's pretty interesting stuff, I thought.
I did too. Well, we're going to be back in just a moment because we've still got, a good bit more to go tonight. But first, let's get a message from our sponsor, ICOM.
Okay.
Advanced technology for advanced communications. Communicating has never been more fun than with ICOM. From D-Star to SDR, ICOM uses the most advanced technology in their radios. The SDR you've been asking for is here. ICOM's new IC7610 is a high-performance RMDR with the ability to pick out the faintest signals even in the presence of stronger adjacent signals. The new ICOM IC7610 is a direct sampling, software-defined radio that will change the world's definition of a SDR transceiver. RF direct sampling system, 110 RMDR, independent dual receivers, and dual digicell. Whether you're looking to enter the world of D-Star or need a backup D-Star portable for your Go kit, the ID31A Plus is the perfect radio. Easy to operate, the ID31A Plus is available in silver, red, or gold. Worldwide communications, share pictures and text messages, and it's IPX waterproof, compact, lightweight, and tough. Find out more about all the great new ICOM radios. Visit ICOMAmerica.com/amateur today.
That 7610, that's a nice radio.
That is a very nice radio.
If you haven't seen it yet, we had Ray, Ray dropped it off, and we did a video about it. It's over on the ICOM America YouTube page, or YouTube channel. Go check it out.
Mm-hmm. It was sure a shame to give it back to him at Rain.
Yeah, but he wasn't going to have it any other way, though.
No, it was going to have to go back.
Yeah.
So
that's okay. It's understandable. It was nice, though.
Yep. They don't give those away as swag.
No. But they do.
They do have some swag.
We do have some swag we're going to be giving away for them shortly.
As a matter of fact, why don't we give that swag away right now?
Hey, since we mentioned it.
That was a really smooth, unintended lead-in.
Yeah. Sometimes accidents happen.
So tell us what you got there to give away.
Well, I'll even do better than that. I'll show you. I've got a nice ICOM America ball cap. It got a nice ICOM Ham Crew t-shirt. So you'll be looking good at the next Ham Fest.
And that's like the t-shirt you just got.
It is. I did manage to get one myself, so I was glad to get it replaced. I don't know what happened to the one I had before, but I'll be hanging on to this one a little tighter.
So what if somebody wanted to get those? What would they need to do?
We give away one every month here on Ham College.
Mm-hmm.
So all you've got to do is send an email to hamcollege@AmateurLogic.TV, and all you need is a name. You don't even have to have a call sign.
A name and an email address.
A name and an email. Pretty much everybody's got one of those.
Yeah.
Or multiple.
Yeah.
Emails. I hope you don't. Some people have multiple names.
As a matter of fact, I found somebody right here on this piece of paper that just happened to have both a name and an email.
No way.
Yeah. And it's our friend Kevin, KD9JOU, and he said, I sure wish I had a couple of Elmers here locally like you guys. Well, thanks, Kevin. Thanks so much. We're going to give you the payoff here.
Yep. You'll be hearing from ICOM pretty fast, and they'll send you your loot you just won.
Yeah.
So you'll be representing well.
Now,
it's really nice, heavy-duty t-shirt.
Y'all see how easy that was? Just send us an email, hamcollege@AmateurLogic.TV, and we might call your name next month. Well, I've got a little something here, a little video. We'll just talk over this because I didn't record the audio with it. I had planned to, but it didn't work out that way.
Well, we can talk over. We've talked before.
Have we?
We've talked over things we weren't supposed to talk over before. So I'm pretty sure we can talk over something we should.
Okay. Well, this is a little video that I shot last night, last minute, of a very old copy of FL Digi that was on my computer. And I ran a little audio into it. And I tuned down so we could just see what a waterfall was and some PSK 31 reception.
Oh, cool.
You can see down at the bottom that little yellow line there with the red above it.
Mm-hmm.
That's our waterfall display down there, and that's only one signal we're seeing there. Up above, you can see the text coming in. That's as it's being copied in direct. Typically, you would see a number of signals down there in that waterfall all at once. The reason you're not seeing it here is, well, I'll explain that in a minute. You see that second signal pop up?
Yep.
Now I clicked over there on that one, and now we'll decode some of that guy's transmission right there. Normally, you're going to see a lot of signals down there. The band was just really bad last night. And I wasn't decoding anything at all. I mean, I could pick up no PSK 31 signals whatsoever on FL Digi there. And what I did is my IC 7700 has a built-in PSK 31 and RIDI, so you can just plug a keyboard in and use it with that rig. Most don't have that. You know, you're using external software. Right. But it has really sharp filters in it, you know, to really hone in and get right on top of a single PSK signal. And I just flipped the PSK button on my rig there, and that tightened it up so tight and peaked that signal up that I was able to decode it over on FL Digi then. Yeah, okay. But that's the reason we only saw the one little signal.
Much bandwidth.
Yep, because it was narrowed down that much.
Yeah, because I remember when we worked it on field day, that's all I ran one field day, I think, for most of it, and they were just all over.
But that's just an example of how bad the band was last night, and how few people were actually on at that time. That's the only way I could pick up a signal. Normally, it's crowded with it. You'll see, you know, a lot of different signals in the waterfall there.
Right.
So
yeah, it's a fun mode. I should really do more of that. I enjoyed it. I don't have it set up on my new computer now. I need to take time to do that, but
takes 5 minutes.
Yeah.
It's worth doing. We'll look at that. Maybe we'll look at that some more in the future here.
Yeah. Maybe we should.
Actually hook up and run some one night.
That'd be good.
Might even be able to talk with some folks over here in the chat room. Who knows?
I bet you we could.
Okay, back to the questions here. What is indicated on a waterfall display by one or more vertical lines adjacent to a PSK 31 signal? Is it A, long path propagation?
B, backscatter propagation?
C, insufficient modulation?
Or D, overmodulation? And I think that's going to be D, if I remember right. Because I remember seeing that. I'm going to go with D. Overmodulation.
Yeah, I'm going to agree with you. Because it's kind of splattering out, and that's typically what you'll see. And that's how people will know that you're overmodulating really easy.
Yeah, and they'll call you out on it too.
They will. Yep. So yeah, I'm going to agree. It's D. Most of the folks in the chat room are saying D. There was a C in there, but yeah, it's D.
Okay, what does the number 31 represent in PSK 31? A, the approximate transmitted symbol rate.
B, the version of the PSK protocol.
C, the year in which PSK 31 was invented.
D, the number of characters that can be represented by PSK 31. Okay. The number of characters that can be represented. Well, we know it's way more than 31.
Yeah, I only see one that really makes much sense.
So it's not D. The year it was invented. No, that's not it at all. It hadn't been around that long either. So it's not C. B, the version of the PSK protocol. That's a possibility. A, the approximate transmitted symbol rate. And it uses varicode, so... But there's got to be some difference in it. So, yeah, I'm going to say it's the approximate transmitted symbol rate.
I would concur with that.
And by
That's the only
symbol...
one that really makes much sense.
Yeah. They're a little mixed in the chat room, but I think it's people are
Some of
probably
these digital ones are kind
there.
of tough. If you're not a big digital guy, and a lot of these you wouldn't even know anyway, even if you use digital every day, unless you just kind of looked into the workings of it.
There you go. A, the approximate transmitted symbol rate. If you're looking at it, PSK31 is just about real-time typing mode for most folks.
Yeah.
So, all right.
Cool stuff.
Which of the following can be a symptom of transmitted RF being picked up by an audio cable carrying AFSK data signals between a computer and a transceiver? Is it A, the Vox circuit does not unkey the transmitter?
B, the transmitter signal is distorted.
C, frequent connection timeouts?
Or D, all of these choices are correct. Okay, we're going to have to read that again. Which of the following can be a symptom of transmitted RF being picked up by an audio cable carrying AFSK data signals between a computer and a transceiver? Vox circuit does not unkey the transmitter. So if it picked up noise on the line, I would think that would probably be a possibility. B, the transmitter signal is distorted. That sounds plausible as well. C, frequent connection timeout. So if you got noise on the line, I could see that too. So I think it's D. All of these choices are correct.
Yeah, they're kind of mixed over in the chat room, but I would say it's D as well. I think all those things would happen.
All
right
three
there.
of those seem like they could be a symptom of it.
There you go. It's a D here. I didn't give you one of these earlier, so you can take that now. We'll be back in just a moment. Don't go away. But first, this message from hamstudy.org and maybe a little something extra. Are you new to the ham world or an existing amateur operator who wants to take your license to the next level? Study for your radio license exam at hamstudy.org. Hamstudy.org is a free online learning tool powered by ICOM. It was created by Richard Bateman, KD7BBC, Michael Stuffelbein, KV9G, and Rich Porter, KK6GKE, and it uses a modern web design to enhance the experience of studying for your technician, general, and amateur extra exams. Since 2013, hamstudy.org has helped new and existing hams to familiarize themselves with the question pools, use stats-based flashcards to focus on material they need to learn, and take practice exams to gauge progress. Visit hamstudy.org on your desktop computer or mobile device. Register for a free account at hamstudy.org to access personalized study history and other site features. Prepare for an exam in an intuitive and comprehensive manner. Check out hamstudy.org, powered by ICOM, for free learning tools. Good luck on your next exam.
As everyone knows, rainbows usually have a treasure at the end. Let's follow this one and see if we can find the pot of gold.
Father, I suppose you've come to claim me treasure.
Well, we'd like to see the gold first.
Faith in there's better than gold in here, me lad. No, just look here, no.
Candy, refreshing soft drinks, popcorn, ice cream. Well, that's some treasure, but anyone can buy luscious treats like these at the snack bar.
You don't tell me. Do you suppose you could get me a job as a snack bar attendant?
Now you're looking at the underside of a television set. And every one of those coils and condensers, the resistors and transformers in that maze of wire is essential to the reception of either picture or sound. Now, those are 300 sources of possible trouble. So it takes a real expert to isolate and correct that trouble if something should go wrong with your television set. You know, becoming a television repair specialist entails long training, and it takes constant study to keep up with the ever-changing circuit designs of 1,000 or so different sets. But even skill and knowledge are not enough, because good television service is a permanent business that requires a stock of over 600 different parts and tubes. So you can see that when something goes wrong with your television set and it needs a bit of attention, you need to find a qualified service specialist, like the man who displays this Sylvania radio and television service sign. For at that sign, you're going to find experts who have the latest, last word, up-to-the-minute Sylvania test and repair equipment and those fine, rugged, long-lasting Sylvania tubes. So the man at this sign depends on Sylvania for quality materials. And believe me, you can depend on him for expert service at really fair prices.
New Cutlass now.
Sure handles easy.
Drive happy. Cutlass can make you a little drive happy.
I forgot to get the newspaper.
Glad we ordered these swivel bucket seats.
Yeah, in case I get to drive someday.
The Cutlass S, Oldsmobile's sporty fastback at a price that's less than you might think, to help make you really drive happy.
Drive happy.
Can I drive now?
I don't remember those things having a swivel bucket seat.
No, but it's a great idea. They should bring that back.
Yeah. I know I'd like to have one. It's probably a safety hazard or something.
I would imagine so.
Yeah. You wouldn't want to be going down the road and all of a sudden you're looking out the window.
Looking into the back seat.
Yeah. All right. I got some more questions here, Tommy.
Oh, just so happened to, huh?
Just so happened to.
Okay. Which of the following would reduce RF interference caused by common mode current on an audio cable? A, placing a ferrite choke around the cable.
B, adding series capacitors to the conductors.
C, adding shunt inductors to the conductors.
Or D, adding an additional insulating jacket to the cable. Well, I happen to know the answer to that.
I think I know the answer to this one.
Yep. Well, let's go through it there. Start at the bottom. D, adding an additional insulating jacket to the cable is not gonna. That's not going to stop RF at all. You're still going to have RFI. C, adding shunt inductance to the conductor. Shunt would mean like parallel. You're going to connect one side of an inductor to your signal lead and the other side to ground. Well, that's just going to short out your signal. That's not going to reduce RFI, because an inductor, typically as you go up in frequency, it's gonna kind of block it. Well, so everything below that, yeah, I'm not saying that right, but anyway, it's not.
I know just what you mean.
Yeah. You don't short out your signal with an inductor going to ground. C, add a series capacitor to the conductor. No, you would put the capacitor, you wouldn't put it in series with the conductor. That won't block any RFI. And I've heard about these ferrite chokes around, and I know placing a ferrite choke around the cable is supposed to help reduce RFI. So I'm going to go with that one, Tommy. You know, that's really only good answer there. There you go.
Yep, that's one I thought it was.
The old Ferrite choke.
I've seen that work before.
Yep.
When I had that other radio in my truck, you know, I had a lot of noise, alternator type noise in there.
You know, that doesn't always work, but in a lot of cases it does. So it
just depends on where it's coming from at the time.
Yep, and how it's getting into
But it's an easy, cheap way to try to eliminate noise first.
Which of the following might be useful in reducing RF interference to audio frequency devices? A bypass inductor.
B, a bypass capacitor.
C, a forward bias diode.
Or D, a reverse bias diode. Okay, so I think I know what the answer is to this, but I don't know the reasons why the others are. I think the answer is going to be B, a capacitor, a bypass capacitor, which I think would be basically the same thing as some people call it, a filter cap.
So, okay, go ahead with your explanation.
Okay, so I think that's gonna block some of the current where the noise is coming from. Now the other ones, I don't know, you know, why they typically wouldn't, you know, not the one, but I think that's the answer. I do know typically capacitors are used to filter out noise on audio lines.
And you'd use the term a bypass capacitor. Now, what they mean there, it's a capacitor tied from your signal lead to ground. It's like in parallel, or it's like we said, a shunt inductor a while ago. Now, they call it a bypass capacitor, just a capacitor to ground. And what that does is, if there's any RFI on that line, it just shorts it to ground.
Sort of taps it.
Taps it to ground. Yeah.
Okay.
So, I'm gonna say B. It looks like the chat room is mostly saying B there. So yeah, bypass capacitor.
What is the effect on an audio device or telephone system if there is interference from a nearby CW transmitter? A, on and off humming or clicking.
B, a CW signal at a nearly pure audio frequency.
C, a chirpy CW signal.
Or D, severely distorted audio. Well, let's see, a CW signal, what kind of interference is that going to cause? Well, CW means continuous wave. You're just turning a transmitter on and off, essentially. So a chirpy CW signal, well, I wouldn't think that's the answer. Severely distorted audio, well, no, you turn the carrier on and off. There's not really audio there. B, a CW signal at a nearly pure audio frequency. No, but I could see it being A. You hear an on-off humming or a clicking as the transmitter is keyed and unkeyed. I'm going to say that's it.
I would think that would be it.
That's what most of them are saying over there in the chat room. So there you go. On-off humming or clicking.
You nailed that.
I nailed it. That was that clicking sound you heard.
That was. Yeah. And I heard some humming.
What sound is heard from an audio device or telephone if there is interference from a nearby single sideband phone transmitter? A steady hum whenever the transmitter is on the air.
B, on and off humming or clicking.
C, distorted speech.
Or D, clearly audible speech. What sound is heard from an audio device or telephone? Audio device or telephone if there is interference from nearby single sideband. A, steady hum whenever the transmitter is on the air. I don't think that's not going to be it because sideband doesn't send a steady signal, so it's just when it's modulated. B, on and off humming or clicking, and that's basically the answer to the previous question. C, distorted speech. The other one's D, clearly audible speech. That's not going to be right. So it's going to be C, distorted speech. So you're going to hear, basically, I guess, the sound that you would hear, if you weren't exactly tuned in on the right sideband frequency or similar to it.
I'm going to agree with you, and because I've heard it a lot of times right here in the shack,
Yeah.
It's pretty common if you've got RFI coming into an audio device, you're going to hear a real distorted speech. Which kind of works out, because if you're interfering with your neighbors, they can't really tell who it is or what they're saying.
Yeah, but you don't want to do that.
But you don't want to do that. But distorted speech, and they were all saying
But
it
it
over
does
in the
happen
chat room.
occasionally.
Yep.
Which of the following may cause interference to be heard in the receiver of an HF radio installed in a recent model vehicle? A, the battery charging system.
B, the fuel delivery system.
C, the vehicle control computer.
D, all of these choices are correct.
I should have kept this one.
Yeah, you should have. I think this is a freebie here. It's D, all of those things.
Yeah,
could
I've
cause
seen every one of them cause a problem. I'm sure you have as well.
Yep. Yeah, I don't know if I was looking at that right, but there was some disagreement on that one. But it's all of those, I'm pretty sure. Let's see. Yep, all of these choices are correct. Well,
It's a pretty tough night tonight.
Yeah, it was, and in judging by the, following the chat room there, usually those guys are bam, bam, bam. They got every one of them just right, but there was some disagreement.
A few of them got stumped tonight.
Yep,
it happens.
We got one more question so they can redeem themselves.
Okay, you totally redeemed yourself.
Yep. Which of the following could be a cause of interference covering a wide range of frequencies? A, not using a balun or line isolator to feed balanced antennas.
B, lack of rectification of the transmitter signal in power conductors.
C, arcing at a poor electrical connection.
D, using a balun to feed an unbalanced antenna. I see the one out there. It has got to be C, arcing at a poor electrical connection, because that sends out noise over such a broad range of frequencies. It's just basically can wipe pretty much everything out.
So
I think it's going to be C.
Which of the following would cause interference covering a wide range of frequencies? Yeah, I think I'm going to agree with you. And it is C, and there was no disagreement on that over in the chat room.
Yeah, because that is notorious.
And just as we're going to be back and do a little demonstration of that, we just happen to
Are
have...
we going to interfere with a wide range of frequencies when we return?
All at once.
All at once.
We're going to get out of shortwave radio, though, and see if that is true.
And the fire extinguisher.
Yeah. We'll be right back.
On the 15th of each month, ICOM is proud to sponsor AmateurLogic.TV with hosts George Thomas, Tommy Martin, and Peter Barrett.
This looks a little crude, but roughly here's what I have. The bottom trace here is ground.
While the elements will jiggle some, they're actually not too bad. It's light.
After putting it together, I decided to test everything, so I ran in 12 volts, and I'm measuring the output here.
No, it's not too windy right now, Jim. It was yesterday.
Actually turn that into a scanner capable of tuning across a wide range of frequencies.
Whoa, okay.
What is this called?
We're in the antenna switching matrix. Any one of our 6 broadcast transmitters could be connected to any of the 22 antennas via the switching matrix.
Down in Melbourne, apparently they tune up their radios different than we do, Tommy.
Oh, yeah?
Now, the FM 900 is tough. Seriously tough.
We finally arrived.
Man, we're in ham nirvana.
Again. Boy, what a great time. And as happened last year, we still haven't got all the way through the flea market yet.
No, we've hit about a fourth of it, but we're going to have to strike a trot.
Well, the moment of truth has arrived. I've attached a B and C connector to the antenna terminals here. I've got plus 12 volt in ground power coming in here. It's going to my power supply. That I'm supplying it with 13.8 volts.
And I personally am so thrilled that George got the special award. Well deserved, my friend. That's really cool.
Yeah,
what about the Super Bowl, Emil? Did you go to the Super Bowl, or were you at home operating that night?
Tuning my amplifier, and I lost power in the shack, and went outside. The house lost power. The whole neighborhood went out for about 30 minutes. I don't know what happened.
That explains a lot.
All right, Tommy, sing the theme song here.
I have got my DX398 shortwave receiver here. We've got the spark gap transmitter sitting on top of some kindling.
Yep. Just so we know it's insulated from the table so that we won't catch the table on fire.
We can't promise anything about the cardboard box, though.
And we've got the spark gap transmitter. You know, we built this in an early episode of Amateur Logic. It wasn't episode 1 because originally this was or Ham College, yeah. Originally this was a CW clicker.
Oh yeah.
And then we upgraded it to be a spark gap transmitter.
Upgrade.
Yep. It wasn't a transmitter to start with, it was just a sounder, but we took care of that.
Mm-hmm.
So what we've got basically is a piece of metal here, an electromagnet, and we got a little loop of wire right here that is going to have a voltage on it whenever we press the our custom CW key here. And that's going to make a heck of a spark right there. I don't know how much you'll see it on the camera.
We'll be having these keys on eBay if you're interested in getting one of them.
So this is our pine board transmitter right here.
Yep, that's the original.
Mm-hmm.
Doesn't have quite the bells and whistles Bob's has.
No, not quite. And I'm not sure the signal is as clean.
No, but you don't even have to tune this one. It's self-tuning.
Well, yeah, I think they improved on these, as time went on, but this is our primitive attempt at it. I've got an AM radio here. Got it on 520 kilohertz. Fire me up there, Tommy. Let's see if we can hear it. Oh yeah.
I hear it.
All right, I'm gonna jump up the band a little bit.
You feel heat?
A little heat, yeah.
It's gonna. The good thing we're doing before summer gets here. Good.
I'm gonna jump to the opposite end of the AM band. We're up at 1710 now. Let's see if you still hear it. Yep. Y'all can't see it on there, but that's a nice little arc on there.
You can't.
Okay, so I'm going to jump up in frequency here a little bit. We're at 1.7 megahertz. Let's jump up to, let's go to 10 megahertz and see if we still hear it.
If we keep doing this, we're going to have to open the back of your computer up again and get another one of these expansion slot covers out.
Yeah. Let's see if we got it at 10. Yep. Pretty good there at 10 megahertz. So I'm going to jump up. Let's go on up to 29 megahertz. And the reason I did that instead, because this won't go to 30. It stops at 29,999. Let's see if we got anything. Oh, really bad there.
We're getting really close on the frequency now.
I think we're getting resonant.
I think we're about to find the the transmitter.
Yep.
The Fox on it.
So, anywhere from 500 kilohertz to 29 megahertz. We had a signal there.
Yep, and all the neighbors' cordless phones quit working.
I don't think it bothered their Wi-Fi, though. I don't think it really went that high. But anyway, so we were just doing a little.
That's an interesting thought. I would need to bring my SDR receiver up here
and see it,
just to see exactly where it goes. Maybe we'll do that sometime.
That could, or I could use a spectrum analyzer, or
Whichever.
Whatever, yeah. All right. So much for that demo.
But you should have seen the spark. It was a thing of beauty.
It was.
It was.
Yep. You just have to take our word for it, just like you do some of the answers we're giving you are right. Tommy, what if you had need for a new wardrobe?
Well,
where would you go look?
The first place that I always go when I need new wardrobe is...
If you can't win it from ICOM...
Yep, I'll go buy it at AmateurLogic.spreadshirt.com. You know, there's a fantastic selection there of the most stylish attire to be found in the ham radio community.
I like the way you said that, yep.
So anyway, if you haven't got Amateur Logic or Ham College swag, find your way over to AmateurLogic.spreadshirt.com today and get some.
And you can find all your favorite Amateur Logic and Ham College swag right there.
You know, speaking of that, Dayton is coming up.
It is, isn't it?
So if you're going to Dayton, be sure to wear the colors and represent. So.
Yeah.
Even if you don't, you should stop and say hi.
We're down to 2 gold PL259, so I think we will have to stock
up. Are we doing
up.
that again this year?
We might. I don't know. We should have bought some in advance.
Yeah. Maybe do something. We'll talk about it.
Yeah.
Figure something out. But anyway, we'll definitely get your picture taken and end up on the show.
Yep. Join us around the 15th of April for the next Amateur
15th
Logic.
of April. Have your tax checks ready.
Yep.
73, everybody.
You can. We need to set up a website where they can send their tax checks. No. All right. 7-3. We'll see y'all next time.
73.
I guess you could ask me this one.
Let me get this bar down from here.
Yeah, I don't know why that bar is there. Well, I do know why it's there, but hey, there's your answer.
Okay.
That works kind of, doesn't it?
Yeah, it's like you're in the
incognito
witness protection program or something.